Alright, so I want to go through a quick kind of breakdown of how to expand brackets, and this is a relatively simple case where we just have one number in front of a bracket. Keeping in mind that brackets are kind of, I don't know, a way for us to show mathematically that everything inside of those brackets we need to treat as like one thing. So I don't know, you might have pizza, right? But like the cheese and the pepperoni and the sauce on top of the pizza, they're all part of that pizza. They're all part of the same thing. So in this case, the 3x and the 5 are all kind of part of what's in this bracket. You can't separate them out without dealing with the brackets first. So when we're expanding brackets, we want to keep in mind that there's a little tiny invisible times sign between the thing in front and the bracket. So we have an invisible times. And what that means is we need to go 2 times everything in those brackets. So 2 times all that crap. And if we think about that, what that ends up doing in this case is that we need 2 of these brackets. 2 sets of them. Or 2 lots of, some people talk to. So really 2 times 3x plus 5 is the same as having 3x plus 5 and a second set of 3x plus 5. And then trying to figure out how much that is altogether. So that's one way to think about it. We need 2 of everything. So what we're going to do to solve for this is we can take what we call sometimes the claw, just to draw it out. But what I need to do is I need to times that 2 by everything inside, because I have to divvy up all of that and multiply it all by 2, because it's all inside the brackets. So that problem is saying 2 times everything in the brackets, so that becomes 2 times 3x. Well, what's 2 times 3? That becomes 6, so we have 6x. And then 2 times 5, well that's 10, and we see a plus sign there, so that becomes plus 10. So my answer for that first one is 6x plus 10. Same idea on the next one, remembering you have that invisible times sign. So we need to think about expanding that 5 and putting it onto both of those. So 5 times 2, we just did that, we've got that's 10, and that's easy. And then 5 times this 6a, well, remember when you're timesing what we call coefficients, or the big numbers in front, like the 5 and the 6 here, even if there's algebra or variables like the a, we're just timesing the coefficients together. So really you can kind of ignore the a for a minute and say that that's 5 times 6, but really it's 5 times 6a. So 5 times 6 becomes 30, and the a stays there. And we need to now watch out for that sign, 5 times 6, and there was a takeaway sign in the middle. Another way you can think about that is just doing it all in one step. 5 times negative 6, if you think of those together, will get you negative 30. Now brackets can be a bit trickier when you've got negatives, and that's where people really tend to make mistakes. So you need to really watch out if you see a negative outside your brackets. That takeaway 3, that's the same thing as saying that this out here is negative 3. So I need to times negative 3 by 4m. So what's a negative times a positive? It's going to get you a negative, so we should have negative 3 times 4 is negative 12m. And now I need to take that negative 3 and times it through to this 5. And in this case, it's easier for me to think about doing negative 3 times that negative 5, so I get my signs right. Because what's a negative times a negative? That's going to be a positive. So negative 3 times negative 5 becomes positive 15. So you'll notice in that original problem, that negative 3 carried through, it changed the 4m into a negative 12m, and the negative 3 times the negative 5 changed that to a positive 15. The last example I'm going to look at with you guys is where there's actually no number in the front, just a negative sign. And that might seem kind of weird, but you can remember that in algebra there's often what we call invisible ones. So there's an invisible 1 and an invisible times sign, because in algebra we often sometimes just don't write the 1, probably just to make it more confusing for people. But regardless, mathematicians do that, so we've got to get used to the idea if you don't see a number in front of something like a set of brackets or in front of a letter, you can assume that there's a little invisible 1 there. So this becomes negative 1 times everything inside. And again, because it's a negative, I got to take that with it, so get in the habit of circling that. That's negative 1 times 4 gets you negative 4, and negative 1 times 3a gets you negative 3a, And if you wanted to, if that was confusing, you could still think that there's the positive sign there, but plussing a negative is really the same as just doing subtraction. And for me, another way I might think about that is, say, what's negative 1 times a positive 3? That becomes a negative 3a. So your answer there again is negative 4 minus 3a, or negative 4 negative 4 plus negative 3a, however you want to think about that. So watch out for your negative signs, make sure you take them through, and if there's no number in front, you can assume that there is a little invisible negative 1.